My name is Sarnaja, and you're watching Brain Security. We are solving the advent of cyber by TryHackMe, and we are on day 14. And today's topic is containers, DoorDasher's demise. Let's get started with the story. It seems as the sun rose this morning, it had already been decided that today would be another day of chaos in Wareville. At least that's the feeling all the folks at DoorDash got. DoorDash is Wavell's local food delivery site, a favorite of the workers in the TBFC company, especially on long days when they get home from work and just can't bring themselves to make dinner. We've all been there, I'm sure. Well, one Wavell resident was feeling particularly tired this morning and so decided to order breakfast, only to find King Malhare and his bandit bunny battalions had seized control over yet another festive favorite. DoorDash had been completely rebranded as Hopperoo. All of the ware's favorite dishes had been changed as well. Reports started flooding into the DoorDasher call center, and not just from customers. The Health and Safety Food Organization was on the line too, utterly panicked. Apparently, multiple Wareville residents were choking on what turned out to be fragments of Santa's beard. Wareville's authorities were left tangled in confusion today as Hopperoo faced mounting backlash over reports of culinary impersonation. Customers across the region claim to have been served what appears to be authentic strands of Santa's bread in place of traditional noodles. A spokesperson for the Health and Safety Food Bureau confirmed that several dinners required gentle entangling, and one incident involved a customer achieving accidental facial hair synchronization. Immediately, one of the security engineers managed to log on and make a script that would restore DoorDash to its original state, but just before he was able to run it, Sir Carradbane caught wind of his attempt and locked him out of the system. All was lost. The SOC team realized they still had access to the system via the monitoring pod and uptime checker for the site. Your job as a SOC team member of DoorDasher, can you escape the container and escalate your privileges so you can finish what your team started and save the site? Very dramatic story. Learning objectives: learn how containers and Dockers work, including images, layers, and container engine. Explore Docker runtime concepts such as sockets and daemon API, and common container escape and privilege escalation vectors. Apply these skills to investigate image layers, escape a container, escalate privileges, and restore the DoorDash service. Do not order Santa's beard pasta. The writer of this particular room is very humorous and dramatic. Okay, we will start the machine later. Let us first see the theory. What are containers? I have a very good analogy for you to understand. Using this simple analogy, let us try to understand what are containers and why do we need them. Okay, imagine that you create a bookshelf, just for example, and you want to send it to somebody's house. Okay, now the environment at your place is going to be different as that of the receiver's place. Temperature would be different, configuration like setting in the house, but nuts and bolts and everything is going to be different, right? So you need to ensure that it is the same as how it looks in the receiver's place. So you use two approaches. First is you take the entire built shelf, put it in one box, and then ship it, right? This is approach one. And in approach two, what do we do? You write the complete manual, you tell that we will need exact these kind of things, and you send the blanks and screwdrivers and things like that, and then you put it in the box and then send it to the receiver's place. Now, since these two environments are different, there is a possibility that shelf will break down. It will not be as it was intended to be. Similar thing happens with software and applications. What is ran on the developer's environment is difficult to run on the users or the destination environment as well. So that is where Docker comes into action and helps you out. It takes your application, bundles your entire product, including the code and dependencies that it needs, and puts it in an isolated box and then delivers it to the place. This is containerization. I hope I'm being clear. Let us go back to the room and read the theory. We first need to understand the problem it fixes. Installation. Depending on the environment the application being installed, it's not uncommon to run into configuration quirks, which make the process time consuming and frustrating. Troubleshooting. When an application stops working, a lot of time can be wasted determining if it is a problem with the application itself or a problem with the environment it is running in. Conflicts. Sometimes multiple versions of application need to be run, or perhaps multiple applications which need, for example, different versions of Python to be installed. This sometimes leads to conflicts, complicating the process even further. If reading these problems, your brain conjured up the word isolation as a solution, well, you're on the right track. Containerization solves these problems by packing applications along with the dependencies in one isolated environment. This package is known as a container. In addition to solving all the above problems, containerization also offers further benefits. One key benefit is how lightweight they are. To understand this, we will now take a brief look at the architecture. Containers versus virtual machine. The most basic difference that you can tell between containers and virtual machine is that the virtual machine is an entire house. It has its own operating system and it has space for applications to run, and you can think of it as whole house including all the rooms. Containers is a single room that is only responsible for executing or running a particular application only. We will come across this concept of microservices later. Illustrate like the ones been booting up on this platform through advent of cyber. A virtual machine runs on a hypervisor software that evaluates and manages multiple OS on a physical host hypervisor. It includes a guest OS, making it heavier but fully isolated. Containers share the host kernel, a host OS kernel, isolating only applications and their dependencies, which makes them lightweight and fast to start. Virtual machines are ideal for running multiple different operating systems on legacy applications, while containers excel at deploying scalable, portable microservices. For example, you have an e-commerce application. They have different services, right? You view products, you add to cart, you make payments, you log in, log out. Now, all these particular services are called microservices. So for that, particular containers can be used. Applications at scale. Microservices are a switch in the style of application architecture where before it was a lot more common to deploy apps in a monolithic fashion, that is built as a single unit, a single code base, usually a single executable. Everything is just put together into a single executable. More and more companies are choosing to break down their application into parts based on business function. This way, a specific part of their application receives high traffic loads. They can scale that part without having to scale the entire application, right? You only scale the certain services that are in high demand for the particular moment, and for that you don't need to carry the entire bundle together. This is where the lightweight nature of containers come into play, making it incredibly easy to scale to meet increasing demands. They become the go-to choice for this increasingly popular architecture, and this is why over the last 10 years you have started seeing the term even more. You've noticed a layer labeled container engine here. Infrastructure, OS, container engine, infrastructure, hypervisor, and virtual machines. A container engine is a software that builds, runs, and manages containers by leveraging the host system's OS kernel features like namespace and C groups. One example of container engine is Docker. It is open source, which we will examine here, is a popular container engine that uses Docker files, simple text scripts defining app environments and dependencies to build, package, and run applications consistently across system. Docker is container engine of a choice at DoorDasher, the application that in this particular room that we have to fix, and so is what we'll be interacting in our lab. Docker uses this one text script to define everything, and we are going to target that particular script in order to gain access. Docker, open source, build, deploy, and manage containers. Containers are executable units of software which package and manage the software and components to run a service. They are pretty lightweight, and we know that. Now, escape attacks and sockets. A container escape is a technique that enables code running inside a container to obtain writes or execute on the host kernel or other containers beyond its isolated environment or escaping. Meaning, whatever you locked in the container has enabled to get access to the root controller. That is the Docker main file. For example, you packed the bookshelf and along with that, you accidentally dropped in your warehouse key, and using that they can come and ruin your warehouse, something like that. That is what is escape attack in relevance to container. Then we have containers are client server setup on the host. The CLI tools act as a client sending requests to the container daemon, which handles the actual container management and execution. Containers have two parts, CLI and container daemon. CLI receives your requests, and the container daemon is the server that handles those requests. The runtime exposes an API server via Unix sockets. What are sockets? You can just think of as connection points for now to handle CLI and daemon traffic. If an attacker can communicate with that socket from inside the container, they can exploit the runtime. This is how we would create the privileged container with internet access, as mentioned in the previous example. What is our challenge? Investigate Docker layers, restore the deface Hopperoo website and to DoorDasher. Going to walk through. Then we have access point. Now it's time to start using the machine that we did not boot. We have to first run this command docker ps, and we have the services that are running: container id, image, command ports, created, status names, python app, docker entry point, Wareville times. The main service runs at this place. Explore the web application and notice the deface system Hopperoo. We know DoorDash is a food delivery service. Let's explore Uptime Checker. Sounds interesting, this particular service. Welcome to Hopperoo. Search for restaurants. Horrified customer, disappointed diner. Shock pattern. Easter bunnies delivery service. Run the following command to access the uptime checker container: docker exe it uptime checker sh. Just going to copy paste. To log in, check socket access by running this. Docker documentation mentions that by default there's a setting called enhanced container isolation, which blocks containers from mounting the Docker socket to prevent malicious access. So by default, you cannot just come and get access. What we have to do in some cases, like when running test containers, they need Docker socket access. The socket provides a means to access containers via API directly. Let's see if we can. I wonder what happens if we try to run Docker commands inside the container. Try to run this again. Confirm we can perform Docker commands, interact with API. In other words, we can perform a Docker escape attack. Let's instead try to access the deployer container, which is privileged container. Nothing happened for me over here. Yes, we can run the Docker commands inside the container. Now we are going to run this particular command. I will mind check which user we are currently logged in as. Deployer. We got into the privileged container. Now we have to explore this container, find the flag. We managed to make the container where the script to restore this site to its former version. Save the day. Let us try ls total 8. We have root. Can we go into root? Then what is that? And then does that mean we're in the root directory? Let us get away from this apps folder and listers. Okay, yeah, there is things in the particular root directory. We found the flag.txt. Let us say cat flag txt. Docker escape success. I think we'll have to type it. We got the flag. Now we managed to make the container where the script to restore the site to its former version is save the day, run the recovery script in the root directory to recover the app using sudo. The hackers have been defeated. With that run, you can see for yourself by refreshing the site. As a reward, you should be able to find a flag in the same directory as the script, which you can read using the cat command. We already found the flag before reading this. What exact command lists running Docker containers? Docker ps. What file is used to define the instructions for building Docker image? Docker file, I think, mostly. Yes, the main file. Bonus question. There's a secret code contained within the news site running on port 5002. This code also happens to be the password for the deployer user. They should definitely change their password. Can you find it? Can we go to that port? Okay, we forgot the exclamation mark. Like the content, we have plenty more where this came from. Try or container vulnerabilities room. This was a pretty good room. Let me first terminate the machine. Today I will terminate before I complete the room. And yes, done. That is it for today. See you in the next challenge.